Hey y'all, let's take a second and review transformations. So we know that we learned 3 parent functions this 6 weeks. We talked about the cubed root function, the exponential function, and the logarithmic. And we talked about how when we transform their equation, it's like a roadmap to how the graph is transformed. And it doesn't matter what parent function it is, there are certain things that are going to hold true every time. So we said if we ever have a negative outside of my parent function, that means that we will have a flip or a reflection over the x-axis. The next thing we talked about is this letter A. So the letter A is going to be our dilation. Ooh, it would help if I could spell. Our dilation. So what the dilation means is that if I have a whole number, so if I had the number 2 right there, that means I would have a vertical stretch. But if I have a fraction, like 1/2, or a decimal, 0.5, that means I'm going to have a vertical compression. All right, our next one, this H is going to be our horizontal translation. Horizontal translation. All right, so with our horizontal translation, I know that I have to do the opposite. So if I have +3 here, that actually means that I'm moving to the left 3. And if I have -3, that means I'm going to the right 3. So it's important to keep in mind that even though right now I have this H in parentheses, what that really means is like a number inside my group. And we're going to take a second in a little bit to do some examples and see exactly what that looks like. This K is going to be the number outside my group, and K is going to be my vertical transformation. Vertical transformation. I'm going to put a period there. All right, and I know that now is where with horizontal, we did opposite. With vertical, we're going to do the same. So if I had +4, that means I'm going up 4. But if I have -4, that means I'm going down 4. All right, so let's do an example from each of the 3 types of parent functions we discussed. And in this case, I'm going to do like all the transformation for each one. So for example 1, let's talk about an exponential. So if I have f of x equals -3 times 4 to the x minus 2 plus 7. Let's take these one at a time. First off, I see this negative, and so I know one transformation is going to be a flip over the x-axis. The second thing I see is that I have a number outside, right? So I see this 4 is going to be my base, and we don't count that because it's attached to my x plus 2. But this 3 on the outside is a whole number, so that means I have a vertical stretch. I also see I have, I have a number up here with my exponent. It's going to be in my group. So I know that's going to be my horizontal translation, and it will move 2 units right, because I know I have to do the opposite when it's my horizontal. And finally, I have the 7 outside my equation. Since it's outside, I know it's my vertical transformation, and it will go up 7 units. All right, my next one, let's take a moment to think about our logarithmic function. So we've got f of x equals -0.5 times, I just butchered that one. Y'all, I am so sorry. All right, so we're going to have -0.5 log base 10 of x plus 3 minus 2. So again, let's think about all the transformations we have. The first one that I see, if I start on my left, is that I have this negative sign. I know that that means a flip or a flexion over the x-axis. All right, the 0.5 I notice is outside of my log, and it's a decimal, and so I know that that means I have a vertical compression. I also see that I have this +3 that is inside my group. It's inside my argument or my parentheses, so I have to do the opposite because it's going to be horizontal. So I'm going to move left 3. And finally, I see this +2 is -2 is outside of my group. And I know that that is going to move down 2. Because I know if it's outside my group, that means it's a vertical transformation. So we're going to move down 2. So we see that these are patterns that hold true for all my parent functions. It just looks a little bit different depending on what my group is, how I define that. All right, our last example is going to be a cubed root function. So let's do f of x equals negative, let's say 2/7 cube root of x minus 6 minus 9. So again, the negative sign out in front tells me I have a flip. Oh, I just butchered that one too, y'all. A flip over the x-axis. The 2/7 I notice is going to be right outside my group, and it's a fraction, so I have a vertical compression. I also noticed that this 6 is inside, it's underneath my house. So since it's underneath, it's in my group, which means I have a horizontal transformation. So if it's -6, that means I move to the right 6. And finally, this -9 I see is outside my group, which means it's going to be my k. If we look back to our original equation up here. So I know that -9 tells me I'm going down 9. So you guys, I hope these examples helped. But always remember, we can always go back to our original equation, right, our general equation. Think about what letter do I have here? What transfer does that, oh my goodness, what transformation does that represent in my equation? And how is that going to affect my graph? Let me know if you have any questions.